In this problem, a cannonball is launched at 100 meters per second at an angle of 60 degrees. Let's draw the diagram for this problem. First of all, by launching it at 100 meters per second at 60 degrees, the ball has an initial Vx and an initial Vy. The Vx is equal to the velocity times cosine theta. That gives us an initial Vx of positive 50 meters per second. Vy is equal to V sine theta, or 100 meters per second times sine of 60 degrees. This gives us an initial upward velocity of positive 87 meters per second. So as the projectile moves forward, its forward velocity is 50 meters per second at all times. However, it starts out at positive 87 meters per second, but it loses its speed until it gets to the top of its path, where its Vy is equal to 0 at the top. Then it picks up speed again as it falls until right before it hits the ground it has a Vy equal to negative 87 meters per second. The first thing we are asked to do is to calculate how high it rises. So, analyzing its motion in the y direction, we're looking for delta y. In the y direction, it starts out at positive 87 meters per second. At the top of its path, it has 0 velocity in the y direction, and g is negative 9.8 meters per second squared. The appropriate equation to use is Vf squared equals Vi squared plus 2g delta y. Plugging in, we get 0 equals 87 meters per second squared plus 2 times negative 9.8 meters per second squared times delta y. Delta y will be equal to negative 7569 meters squared all over second squared divided by negative 19.6 meters per second squared, which will give us a height of 386 meters. The second thing we're asked to do is to determine how long it's in the air. So we're looking for time. Analyzing its motion in the y direction, we know that it is launched upwards at 87 meters per second. It rises, comes to a stop, and then falls back down. Right before it hits the ground, its final y velocity will be negative 87 meters per second. And of course, gravity is negative 9.8 meters per second squared. The appropriate equation to use will be Vf equals Vi plus Gt. Substituting in, we get negative 87 meters per second equals positive 87 meters per second plus negative 9.8 meters per second squared times time. Time will be equal to negative 174 meters per second divided by negative 9.8 meters per second squared. This will give us a time of 17.8 seconds. And finally, we are asked to calculate the range. To calculate the range, we will analyze the horizontal motion. The only equation that describes horizontal motion is range equals Vx times time. The Vx for this particular projectile is 50 meters per second. The time we just calculated was 17.8 seconds. So the range will be 890 meters.